Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to critique the work of others and examine multiple methods and techniques to solve problems, and how to determine the best course of action when completing problems, and recognize that it is important to have multiple techniques to solve a problem. How are we learning it? Through the critical arguments and true statements notes and the critical arguments and true statements assignment. When can we use this? To organize thoughts and ideas about any topic in order to provide a valid argument for your thoughts, beliefs, and ideas. How do we know we learned it? By getting a score of 4 on the critical arguments and true statements assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the critical arguments and true statements notes, and then I'll give you time to complete the critical arguments and true statements assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your before you go. Your only homework for tonight is to work on any incomplete assignments that you may have. Let's take a look now at the critical arguments and true statements notes. The notes begin with the learning goals and success criteria. Now let's talk about the types of true statements. So there's 3 types of true statements. The first one is always true. A statement is always true if there are no examples that can make it not true. So for instance, the sun comes out today. That's always true. It may be kind of overcast, but the sun is still out. So that's an always true statement. Sometimes true means that there are examples of it being true and examples of it not being true. So we can provide examples on both sides. And then never true means that there are no examples when this ever happens. So, for instance, the sun comes up in the morning. Well, we know that that's always true. The sun always does come up. So that is an always true statement. It will be raining tomorrow. Well, maybe it rains tomorrow, maybe it doesn't. It's possible either way. So that is sometimes true. And lastly, the temperature tomorrow will be 200 degrees Fahrenheit. Well, sometimes it might feel like it's 200 degrees, but it's never actually 200 degrees. So that is never true. Let's look at some mathematical examples of true statements. So the first one says quadratics, which form the U shape, increase infinitely. Well, that's true as long as the parabola is opening up, right? That means it's going up forever in both directions this way. But if it's opening down, now it does stop here and it decreases infinitely. So this is sometimes true. Now, absolute value functions have negative y values. Well, remember, absolute values form the v, and remember, if we have an absolute value, it can't go below the y-axis, so it can't have negative y values, so this is never true. And linear functions have both positive and negative y values, meaning that it's going to cross the y-axis. Well, we know that anytime we have a line, it's always going to cross the y-axis, so therefore that is always true. Some mathematical operations in words that you'll need to know. Sum means that we are adding, difference means that we are subtracting, product means that we are multiplying, and quotient means we are dividing. Some mathematical examples of true statements. The sum of a rational number and a rational number is rational. Well, basically what that's saying is, if I add 2 fractions together, is there any way to get something other than a fraction? Well, we know that we can't get pi or e or square root of 2 by adding 2 fractions together, so therefore this is always true. The sum of a rational number and irrational number is irrational. Well, if I add a fraction plus pi, I will always have that pi, and because they're not like terms, so I can't add them together, so it will always stay irrational then. So that's always true. And the sum of an irrational number and an irrational number is irrational. So if I add pi and pi, I get 2 pi. Well, that's irrational. So it's at least sometimes true. But what if I add pi and negative pi? Well, if I add those 2 together, I get 0, which is not irrational. So therefore, this is sometimes true. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. you're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click Start the Activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google. Let's take a look now at the critical arguments and true statements assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here that'll take us to the Desmos activity. Go ahead and click on that link, and it should take us to a page that looks like this. We're going to go ahead and click Start the Activity. Our activity begins with the learning goals and success criteria. We'll go ahead and click Next. Now for this one, we're going to decide whether it's always true, sometimes true, or never true. So it says the sum of two numbers is larger than each one of the numbers. Is that sometimes true, never true, or always true? Well, we know that if we were to add like 3 plus 4, that's equal to 7, which is bigger than both of the numbers. But what if we were to add negative 3 plus negative 4? Well, that's negative 7, which is smaller than both of the numbers. So this one would be sometimes true. So for each of these, you're going to state whether they are always true, sometimes true, or never true, and then provide examples to show how you know that. So here I provided an example of it being true and an example of it not being true, and therefore it is sometimes true. So you'll do that for each of these, and then we'll click Next. There's more questions just like it. You'll go ahead and continue to answer these all the way until you get to the end. Once you're finished this up, you'll go back to your Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.